All right, awesome. So just to add some color before we get into what Fairblock is and why we're building it. So we think the lack of privacy in blockchains is one of the bigger deterrents to blockchain adoption. And a major reason for that is because without privacy, applications are limited in their designs and utility for a global user base. Without privacy as a standard on chain, we can't build the sticky apps that will onboard the next billion users and the next trillion in liquidity. So we chose to build in the Cosmos ecosystem because of Cosmos' ability to support advanced cryptography libraries built in more popular programming languages like Rust that will allow us to more efficiently and reliably deploy privacy modules on chain, which would have otherwise been too inefficient to do on chain with the EVM. So Cosmos allows us to bring identity-based encryption, witness encryption, and eventually FHE into Cosmos to enable pre-execution privacy and conditional decryption to Cosmos app chains. So let's get into this. So to start, what is Fairblock? Fairblock delivers programmable privacy and conditional decryption to protocols and applications to protect users from malicious actors and the downsides of on-chain transparency. We're able to do this via our Cosmos app chain, which is called Fairyring, which generates and then delivers encryption and decryption keys to any blockchains or to any chain. So this includes Cosmos app chains, other L1s in other ecosystems, L2s. The point is that Fairblock delivers modular programmable privacy really anywhere it's desired. So we think that a modular approach to privacy will more or less crack open the design space for on-chain applications, as developers can now plug in privacy modules into their apps instead of having to build entirely new decentralized trust networks, as was kind of like the current standard before, where you couldn't really plug things in. You just had to build your own network that had the utilities that you wanted it to. So this modular approach to privacy, of course, has use cases that are all over the map, from private governance, for example, which we've already built for the Cosmos Hub, encrypted on-chain intents. These could be limit orders, stop-loss orders, any kind of programmable trading. Randomness generation, for example, for NFT drops or for online gaming or gambling. Censorship-resistant shared sequencing, bad MEV prevention in trading. So no front running or sandwich attacks, encrypted mempools, privacy-preserving rollups, private on-chain games, and so many more utilities that even we haven't thought of just yet, but are actively researching. So let's go over quickly the general architecture of Fairyring. So Fairyring, like I said, is a Cosmos SDK chain. It essentially acts as a decryption key oracle for other blockchains. When there is a request for conditional decryption inside of a Cosmos app chain or on some L2, the Fairyring chain sends over the master public key, and then it generates the derived private key for each of the conditions that are chosen by the users for which their transactions will be decrypted. Fairyring is also a POA chain. So there's a general registration and vetting process for validators that are seeking to participate. Fairyring is made up of three main components: the validators, the share generator API, and the Fairyring client, which is run by the validators. And how this kind of works architecturally is the share generation API. It's responsible for randomly generating the master secret key and dividing it up and distributing that master secret key into master secret key shares, where each of the validators in the network hosts one of those key shares. That key share will be used for the decryption of a transaction once a condition on chain is met. So once the API generates that secret key and then distributes it out to the validators, it then throws away that secret key so that there's no like central point of trust here. And that trust is kind of dispersed amongst the network, and then generates actually, I didn't say this, but before the API throws away the master secret key, it generates the master public key from that, and then throws away the master secret key. And then once that master public key is generated, it then submits it as a transaction into Fairy Ring, where it lives in the Fairy Ring state, and then will be communicated via IBC or via relayers to Cosmos app chains, and then relayers into other L2s or ecosystems. So once each of the validators has their master secret key share, when each of the on-chain conditions for decryption are met, that chain is like the state of that chain is being monitored by what's called Fairyport, which then communicates to the validators that the on-chain conditions have been met, gives them the condition ID to let them know that this has happened on chain, and then the validator can then use the master secret key to derive their own private key share. That validator, once it has their derived private key share generated, it then submits it into Fairy Ring. From there, Fairy Ring's responsibility, once it meets a threshold of an amount of validators that have submitted their derived private key shares, it then performs a function to construct the total derived private key for to decrypt the transaction, and then sends it via Fairyport to the destination chain. In terms of like how this works, the private key construction, for every block that's generated, there is a private key that is also generated. This picture here, this is a screenshot from the testnet block report that we get sent into our Discord. That just presents the latest height of the chain, the number of key shares that are received from each validator. So 7 right now. Obviously, we're in testnet, so that's limited. It's a private testnet too, so that's that's why the validator network is rather small. But once each of the validators submits their key share, the Fairy Ring performs the function to then construct the entire aggregate key, which is right here. And like I said, for each block, that same process repeats. And then also to mention, each block, there is a new master secret key that is generated. So, there is a general recycling process of that key for each epoch, which is, kind of an established number or the block height. So you might be asking, how does Fairblock benefit Cosmos? This is an interesting question. So we think that like the modular approach to privacy preservation will specifically benefit the Cosmos ecosystem first, because as a Cosmos SDK chain, we can send our encryption and decryption keys across chains via IBC. This is, the most kind of direct pathway towards communicating these keys from chain to chain. So with this privacy being modular, it can be plugged in anywhere, and we believe that this extends the Cosmos app chain thesis, where we can now plug privacy into any app chain, which then offers a pathway for all these institutions and individuals. Like I mentioned before, earlier in the presentation, what kind of the roadblocks to blockchain adoption are. Now we have all of these privacy-seeking users who can now interact with an entire ecosystem of apps and liquidity instead of only being able to use siloed privacy-specific networks, as was the standard before Cosmos and before kind of the modular blockchain thesis really took off. So we think that giving these abilities to Cosmos will be huge for the ecosystem development, for user and TVL accrual to the ecosystem, and then eventually and hopefully potential value accrual for the Atom token as the network effects grow larger. Now time for some demos. This is kind of a demo of the homepage of the Fairblock site. I'm not sure if I click on this link, which takes us to it, I will stop sharing my screen. So I'm not going to click on it right now. But basically, like, the website is where you'll go to find any and all information about Fairblock, what we're doing, why we're doing it, all of our utilities, how it works, career opportunities, our blog, and our docs to review, all the technical concepts that we cover. I want to show you now the private governance demo, which doesn't have any words, so I'm going to narrate it for you. Can you guys still see this? Jan, can you see this?
Yes.
The demo video, correct?
Yes, I can see the demo.
Okay. So we're going over just the demo here. You can, here, wait, let me just start this over. This is a demo of our private governance module, which we've built for the Cosmos Hub. So something that requires a vote. The vote goes on chain. You can select to have your vote be encrypted right here with that toggle. And then you have the proof of the vote. Let me go back to that. The proof of the vote up there that it is encrypted. And then we can kind of see like the results of that transaction that are posted on chain. I'm going to escape that. Oops. Present. And then I also want to show a randomness demo as well, which goes over our randomness generation, which is one of our utilities. Hey everyone, I'm Liam, head of growth here at Fairblock, and I'm Jan, could you hear that at that volume from the video?
Yes, ideally mute it or put down the volume of the video if you don't want to hear it.
Okay.
Or just play it like with sound.
Yeah, I'm going to play it with sound. This is just a demo of our randomness here. Hey everyone, I'm Liam, head of growth here at Fairblock, and I'm demonstrating our randomness generation today. So as you can see, we've got a derived private key from the Fairy blockchain that presents for every block that is produced by the Fairy chain. This is the derived private key that all the validators in the chain work together to construct in a decentralized way. And from each of these derived private keys contain the contents for the randomness inside of each of these boxes. This is the color of each box, the size, where it's placed on the page. All of these contents are derived from the derived private key right here. And as we can see, for each block and each secret key that is generated, a new block appears on the page. Thanks so much. All right. So the randomness here is something that we're really excited about. This is going to provide a whole kind of like other corner of utilities for users of Fairblock and the Fairblock chain, for deriving randomness for airdrops or for NFT minting or for any kind of on-chain gambling. There are a ton of use cases. Let's go back here. So that's all for now. For updates, please follow us on Discord and on Twitter. And yeah, what to expect from us from the coming year. We have our testnet launch right after ETH Denver. I will be there, as well as one of our co-founders. So if you want to hang out and get to know us some more, hit us up. We'd love to talk. We've got mainnet at the end of the year this year. And then we're also planning a DoraHacks hackathon that will be announced soon. And then also many exciting partnerships and opportunities for builders to contribute early. So that's all I got.